for the mini lesson? Welcome back. Let's first ground ourselves in our big idea. Our whole purpose of learning anything about fractions to begin with is that what are some ways that mathematicians can represent parts of a whole? Not every number we talk about is exactly one whole number. We break those numbers down all the time, okay? So that's what fractions represent for us. And so we're trying to think of all the ways that we can represent what's happening with those numbers. And with that, why are the numerator and denominator so important? And that's what we're really going to talk about today, once again, is our understanding of the numerator and denominator and how that helps us understand what's going on with a part of a whole number. All right, so let's take that thinking and tie it in with our guiding question for today. Go ahead and read it with me at home. Luke and Kayla, if you want to join in, you can. How do mathematicians use area models and linear models to compare fractions? So that word compare. Yesterday and the day before, we were trying to see what models could we use to see if fractions were equivalent. And now we're going to get even smarter about that using greater than, less than, or equal to. Suki's back. Do you see Suki? Mm-hmm. She really likes to lay in here. The other night she was laying in here and her little tail was on one side. Yep. And her little feet were on the other. You're such a good math friend, Suki. I bet my third graders love you. Thanks for visiting. That's my chair, dude. Watch out. All right, and then the math language we're going to use today as we discover how we compare fractions and then later how we write about it in the Google assignment. Numerator and denominator. Again, numerator's on the top. It's how many parts are being counted. The denominator, we remember, is on the bottom. So we know that that's how many parts are in the whole. And I know when I was a kid, I could never keep them straight, numerator, denominator. So use the bottom to help you remember. And then today our new language compared to what we were working on the last 2 days is greater than, using this symbol, less than, using this symbol, equal to, or you could even say equivalent, that's what we've been working on. And then of course an area model. Here's a circle or a square or a rectangle. You could even use a hexagon. You could use any shape as long as it's representing that portion or fractional part. So how are we going to use these different kinds of models to compare fractions? Let's take a look. We're going to do one together. And then I want you to pause the video each time after we get going so that you can wrap your own mind around it and then unpause it and see if your thinking and my thinking were the same. I bet they will be. So do you remember yesterday we talked about 5/8 and 1/3? And we talked about how 5/8, I'm thinking 5/8, 5 parts out of 8. That is closer to getting to one whole, or 8/8. And 1/3, there's only 1/3 being counted, 1 out of the 3 equal parts. So before I even drew a model, I was already thinking that 5/8 was greater than 1/3, just because of the size of the numerator and the denominator and the amount of fractional space they take up. So that's something that we're going to be really good at, is that maybe we won't even need to draw models later on. We'll just have a good understanding of how the numerator and the denominator interact together to tell us how close they are to a whole number, or maybe even how close they are to 0. So let's first look at the fractions 2/6 and 7/8. And remember our guiding question said we can use area models and linear models to be able to compare fractions using greater than, less than, or equal to. So when I first draw 2/6, I know that I have to have 6 equal parts. I think, let's see, I'm going to use the rectangle again. I kind of like the rectangle. And I'm first going to cut it into thirds, you guessed it, and then cut those thirds in half to get 6. Then you can see it's not perfect. We don't need perfect. We just need as close as possible, right? And then I'm going to shade in 2/6 of those because 2 parts are being counted. So this is 2/6. And then let's look at 7/8. Have you already made a prediction that 7/8, 7 parts out of the 8 total it would need to make one whole? That's going to be pretty big. And I'm thinking compared to 2/6, I might already know that 7/8 is greater than 2/6, but let's have a look and just be sure. So if I were to make 8 equal parts, first I'll cut it in half, and then I'll cut those in half, and then I'll cut those in half. And now I have 8 equal parts, and I'm shading in 7. 1, 2, 3, 4, 5, 6, 7. Sure enough, 7/8 is greater than 2/6. so I can show it with that symbol, okay? When you get to do your own assignment later, the one for the Google assignment, you're gonna do it on paper first, and then put your thinking into the Google assignment. So you can use area models and linear models. I could also draw this on a number line, real quick here. Kayla, where am I at with time?
5.5 minutes.
Okay, so we still have a good amount of time. So if I were showing 2, 6, I would cut it into 3 equal parts first. 1, 2, 3. And then I need 6, so I'm going to cut those in half to have 6 equal parts. 0 6, 1 6, 2 6, 3 6, which is equal to 1 half. Did you already know that? This and 1 half are the same. 3 6, 4 6, 5 6, and then 1 whole would be 6 out of 6 parts being counted. And we're representing 2 6. So I'm going to put my dot right there. And then let's draw another number line. Again, it has to be the exact same size, or we can't even talk about comparing fractions. We're breaking math law. I have my 0 and my 1, my benchmark numbers in the same spot. And then I'm going to cut this in half. And then I'm going to cut those halves in half. And then because I need 8 parts, I'm going to do it again. Now I have 8 equal parts, and I can label out that number line. 0 eighths. Count with me at home. 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, and 8 parts out of 8 equals 1 whole. If you also guess that 4 eighths is also equal to 1 half, you're correct. So we're looking at 7 eighths. That almost looks like a 1. And we can see that 7 eighths, when we're looking at the number line, is closer to 1 than 2 6. 2 6 has a lot bigger jump to get to 1 whole. So that's how we're using our area models and our linear models to be able to compare 2 fractions. Okay, on this next one, I'm going to throw it up here, and then your job is to pause the video and do your own thinking, and then we're going to come back together. But before you pause, just take a look at these 2 fractions. We see that the denominator is different. The 4 is different than 6, and what we know about the denominator is it doesn't follow the rules like we normally know numbers. When I see a 6th versus a 4th, I know that this has been cut into smaller pieces because the number is bigger, so the pieces are smaller. And I see that the numerator is the same, which means we're talking about the same number of counted parts. Okay, so this is smaller pieces, this is bigger pieces, but the same number is being counted. I wonder what you predict as far as whether it will be, did you see this? Look at my mistake up there. Nobody corrected me, come on. Greater than, less than, or equal to. See, I'm old and I still make mistakes. Mistakes are part of the learning journey. I just fixed it and I moved on. Okay, so thinking about these 2 fractions and what we just talked about, what symbol do you think is going to go there? Okay, I want you to pause the video, and I want you to do your own thinking and prediction, and then unpause and see if we match. Okay? All right. All right, thank you, mathematician. Good job. How'd it go? Did it make sense? Were your area models precise? Let's check and see if our thinking is the same. So this first one, maybe I just want to draw a number line or just an area model. I don't have to do both every time. Maybe this time I'll just do a number line. If I'm looking at 3/4, I'm going to show my benchmark numbers 0 and 1. This denominator is saying cut it into 4 parts. I'm going to cut it in half. And then I'm going to cut those halves in half. And then I can start labeling my number line. This is 0/4. Count with me at home. 1/4, 2/4, 3/4, and 4/4, or 4 parts counted out of 4 total equals 1 whole. And so this one is saying, hey, let's put a mark there on 3/4. All right, now we can draw another number line to compare and see which fraction is bigger. Let's see if your prediction matched. My prediction is that 3/4 will be greater than 3/6 because the units are the same up here. They're both talking about 3 parts, but I know that since the denominator is smaller, it's being cut into smaller pieces, that this one's going to be bigger. Let's see if I'm right. I'm going to make my number line the exact same size, and I'm going to put my 0 and my 1 in the exact same spot. And now I'm going to cut it into 6 equal parts. I got to cut it into thirds first. Can you see that okay, Kayla?
Mm-hmm.
And then I'm going to cut those in half, and now I have 6 equal parts, and I can label it 0 6, 1 6, 2 6, 3 6, 4 6, 5 6, and 6 parts out of 6 is 1 whole, and I'm representing 3 6. Which of these is closer to 1 whole? You see that 3/4 is a much smaller jump to get to 1 whole. Makes it so important that my number line is exactly the same size, right? So that I can see what's happening. So then I can show that. I can show that 3/4 is greater than 3 6. My prediction was correct. All right, let's do a couple more, and then I'm going to let you do it on your own on Google assignment, okay? Get in there and share those responses with me. I want to be able to reply to you. Let's look at the fractions 1/2 and 3/4. And I meant to draw a box there instead of the word and, but that's okay. We can fix it in a minute. Pause the video. Do your own thinking on this. Which fraction is greater than? Maybe there's a less than or an equal sign. What are you going to do to figure that out? Area models or number lines? All right, let's take a look. This time I'm going to draw squares. Here I'm going to show 1/2, so I need 2 equal parts, and I'm counting one of them. This is 1/2. And then 3/4, even before I draw it, I'm already thinking that this one's going to be greater, because out of the 4 parts, this one is already counting 3 of them. It's really getting close to that 1 whole. 1/2, I have so much schema about 1/2. I know that's dead center in the middle of the number line, and that 3/4 is bigger than that, because 2/4, remember what we've talked about, is the same as 1/2. So I'm already thinking this one's greater. But let's go ahead and draw a model just to be sure. So here I want 4 equal parts, so I'm going to cut it in half, and then I'm going to cut that half in half, and then I'm going to count 3 of them. 1, 2, 3. This represents 3/4. Which one? How am I going to write this? We can see that 3/4 is greater than 1/2. So let me rewrite the equation since I messed up there. 1/2 is less than 3/4. How'd you do? Is that what you got too? Good job. Where am I on time?
12 or 13 minutes.
13 minutes. Okay, let's do one more real quick. 6/8 and 2/4. Maybe even make a prediction before you do this work on your own. I see that there are 8 parts here, 4 parts here, 6 out of 8. That's a lot of numbers, or excuse me, that's a lot of parts already being counted. That's pretty darn close to 1. And then 2/4. My scheme about 2/4, this is the same as half. I'm already thinking that 6/8 is greater than 2/4 based on the size of the denominator and how many parts are being counted, getting closer to that 1 whole. What do you think? Pause the video. We gotta hurry. Well, you don't have to hurry, because you can take as long as you want when you pause. All right, let's draw quick models real quick. Let's draw 6/8. Cut it in half. Cut those halves in half. So sloppy. 1, 2, 3, 4, 5. There's 6/8. And then I've got to draw 2/4, so my area models have to be exactly the same size. Cut those in half. Cut those in half. Now I have 4 equal parts, and I'm counting 2 of them. So you can see that 6/8 takes up more fractional space than 2/4. All right, so I'm going to show that here, that 6/8 is greater than 2/4. So going back to our big idea, the numerator and the denominator are very important. They really help us understand the size of the fractional parts. Thanks for joining me. We'll see you tomorrow for one last lesson for the week.